The name of this course is Signals and Systems. We're going to start off with what are signals and what are systems. This is one definition I got from one textbook. Our textbook does not have a definition of a signal, but this is what I got from another textbook. An alternate definition. A function representing a physical quantity or variable, and it typically contains information about the behavior or nature of the phenomenon. Both of these are taken from very heavy double E type books. And they both talk about physical phenomena. They don't need to be physical phenomena, though. They quite often are. A lot of stuff you'll be working with are, but they not always are. So these two definitions are really not complete, but there's some place to start, particularly if your book does not have a definition of what a signal is. One thing that is very important is that it's a function. That goes back to prerequisite knowledge we said you needed for Chapter 1. What is a mathematical function? Think back to your Algebra 1 class. What is a function?
Something has an output.
Something has an input and an output. So this is something mathematical with an input and an output. What's another way of describing input and output in mathematical terms?
Independent.
Very good. Has an independent variable and a dependent variable. And that's really the key to a signal. It's got an independent variable and a dependent variable. That independent variable quite often is time. In this class, it's always time. I teach an advanced class on image processing, and there, instead of time, it's space, x and y. So it's got two independent variables. The dependent variable is what we're trying to measure that's conveying the information. So it can be a voltage, it can be your information signal, your dependent variable. And your independent is time. It can be your current, it can be temperature, it can be pressure, it can be a lot of different things. System. It's a device that has an input and an output. The inputs and outputs are signals. Okay, so the inputs and outputs are signals. And that's similar to what we talked about with a function. A function has an input and an output, but those are values. But now these functions are the inputs and the outputs to a system. And that idea can mess with your head a little bit at the beginning, but by the end of the course, particularly the end of the week, you should be much better with the idea. Here are 8 examples of systems. So we'll start up here with the first one. What is that system? Say the obvious answer. It's a circuit. Now we said that a system will have an input and an output. What is the input to that system? Probably some sort of voltage. What is the output of that system?
It could be what you want to measure.
So it could be a voltage or a current across any of the devices that are there. Okay? Now, think of now what we just talked about with the inputs and the outputs. Those are your signals. Look back at your definition of signal and think about how they fit those definitions and how this, as a system, fits the definition. Number 2. What is that system? So if that's your system, what's the input? Potentially. What could be the input?
Force. The engine.
Force from the engine. what other things could be the input? It's not, it doesn't specifically say for this example, but it could be steering, what you get from what you turn on your steering wheel. Okay. What are the outputs likely? Rotation of the wheels, speed at which the wheels are rotating. Could be an angle of the suspension. Okay. Now think again about those inputs and outputs in terms of the definition of signals. It's a force that the engine is applying over time. It is an angle which you are applying over time. And then your output signal is your speed over time, or the rotations over time, or the angle of the suspension over time. You see where we're going with this? Number 3. What is your system? A rocket. And what are the inputs?
Force going straight down.
Okay, the force could be the output of the engine. It could be how much gas is being given to the engine or rocket fuel. What are the outputs?
Thrust or force.
Thrust or force that the engine is able to produce.
Height, elevation.
Elevation of the rocket relative to the Earth. Could be speed relative to a point on the Earth. So a number of different inputs and outputs. Number 4. It's an economic system. I had a husband who had a PhD in economics. Most Americans who go for PhDs in economics in the United States were engineers in their undergraduate, because people who did an undergraduate bachelor's in the United States don't have enough mathematical skills to do a PhD in economics here. So it's an economic system. What are the inputs? Potentially.
So many factors.
Well, pick some that it could be. There's lots and lots of them, so what are a couple that they could be?
Trade, stock market crash.
So the price of stocks, the amount of trade, money supply, what the Federal Reserve is doing,
Commodities, demand.
how much people are purchasing. And again, think of these as quantities over time. And then refer back to the fact that these books, we're talking about there having to be physical phenomena. I'm not sure if you could really say trade is a physical phenomena or money supply is a physical phenomena. But this is just as much of a system, and those are just as much of signals as your voltage and current are. And I don't know really how physical voltage and current are anyways. That's a question there. So if something's got an input and an output is what your system is. And again, those inputs and outputs, it can apply to something which is not really a physical item either. So notice that in my definition of a system, it had device in quotes. You can't hold this in your hand. So it's not a physical device, but it is something that exists and has an input and an output. Okay, what about this number 5? It's a ship. And I like this one. This comes from some work I used to do for the Navy. This is a little bit harder to see, but this is a wire cable on a spool for a towed array, which is something to collect sonar signals in the ocean. So it'll spool out a very heavy cable with a whole bunch of microphones on it to try and listen. Think Hunt for Red October. I don't know if that's too much before your time, but still pretty classic. And so the cable will spool out as the boat goes forward, and eventually you'll spool it back in. So if that's your system, inputs could be what? Okay, on the actual line, the inputs to the line, rather than the whole towed array system, would be the sound going into there. What about for the physical system?
Like for unspooling it, just like the voltage applied to the motor.
Voltage you have to apply to the motor in order to get it to let the cable out or take cable back in. Okay, and the outputs would be
The length of the line.
length the line is deployed. Number 6.
Thermostat?
The thermostat. Inputs,
Change in temperature, or what you want the temperature to be.
what your user wants,
Mm-hmm.
which nobody can ever seem to get right. And the output,
Is what the user wants temperature, or the energy spent to change the temperature.
or the amount that the fans are blowing, the amount the heater is running,
And the temperature of the room itself.
the net temperature of the room that you're trying to regulate. Number 7,
The sound system.
it's a sound system, an audio system.
Your input would be the singers, or whoever's speaking in the microphone.
Okay,
The output is coming out of the speaker.
potentially. There's other options, but that's one we'll work with in a little bit. And another circuit, which is related to number 1, but has a little bit more characteristics to it. So you can see how these definitions apply, and really how they do not have to be these physical items that some of the books say they have to be. Also, I want you to focus on how these inputs and outputs, if you look at each of those signals, your voltage or current over time as they function with an input and output, but your system has these signals as inputs and outputs. And that concept is a necessary one for this class, particularly as you work on first homework assignment.